Okay, so while we're waiting, we'll just be playing a little catchphrase game.
Every time we have this beginning, I always think we need to have music in the background. I'll remember that for next time.
I'll scramble for the orb on my Spotify playlist. I love that song.
We should have had Christmas tunes this time.
Damn it. What a good idea. Oh.
Sorry.
I was just saying, if anybody has any ideas, they can pop it in the chat as well.
Yeah. To see the chat. Can be looking at the second one as well. So the second one is this, and then I'll show the answers in a second once we've got everyone that's joined. Apparently there's a mainframe playlist. Okay, Nick. You're in charge.
Teenage kicks must be there.
Okay, right. I think we're just about ready to get started. I think it's, oh, there's still lots of people joining. I think we'll just get started. Okay. So, welcome everybody to our MainframerZ Meetup event. So this one's going to be focused all around cloud modernization in the mainframe. And this is specifically a theme that someone asked for last event. So hopefully we've got some good topics that satisfy that criteria. So the answers to our, what's the game show called? Catchphrase? No, not catchphrase.
It's countdown or
countdown. Yeah. So the answers for our little game are cloud modernization, the first one, and then the second one is mainframes run the world. So well done if anyone did manage to get those. So what is Mainframers? I feel like we go through this every time, so sorry if you are a regular, but every time we have new people join, and particularly this event, I saw lots of new people registering. So just as a quick overview, the MainframerZ Meetup is just a group of us from different companies that just get together in our spare time to arrange these meetup events, focused around the mainframe just purely because we have interest in it. And the event started out in London in person, but obviously have been online since the pandemic, and we've managed to reach out to a lot more of you, and we're getting lots more people from around the world joining each time. So that's great. And obviously we need to think about when we can go back in person, how we can keep it so that we keep this community going and we can still reach out to all of you. So this is just a handful of us that make up part of the core team, but there are more people as well that can't fit in the slide. So we tend to meet up every couple of weeks in an evening and kind of plan the events, but we're always willing for, or we always want more people to join us. So to get involved, we've got the main meetup page, which is really good for you to join because then you actually get notifications and things when we set up new events. We've got a Slack channel or a Slack workspace. So if you come and join that, then it means that we can carry on all the conversations between meetings, and you can have an input into how we plan the next meetings and things like that. We've got LinkedIn and Twitter as well. And the Slack, I've lost my mouse. The Slack link, if anyone hasn't joined before, I'm just about to post in the chat. You have to have the invite link to be able to join it. So please do come and join us there. So we're always looking for more people to get involved. So if anyone wants to come and be a part of the team, we meet on a Thursday every 2 weeks at 5:30. So after work, so we're doing this outside of work time. And we always want more people to join. So please get in contact if you're interested in joining us. And in terms of other opportunities, so as I said, we're always interested in getting more organisers. We're always wanting more speakers, and that's probably the hardest bit, trying to find speakers for each event. So if anyone has a particular topic that they'd be willing to speak on, please do let us know. There've been quite a lot of discussions recently about people looking for new jobs and equally recruiters looking for jobs. So if there are any recruiters that would like to get in contact with people, that's also a great way to get involved. And we're also always looking for people to host the events. So doing what I'm doing today and introducing the speakers and that kind of thing. But aside from all that, it's still super important for you all to just be a part of the community. So what you're doing today is you're attending the events, which is great. And then outside of that, being able to drive the community, spread the words, tell people you work with about the events and get them to come in future, just kind of engage going forward in between events, and most importantly, giving us feedback so we know what to put together for the next events that's worthwhile. So for today's sessions, we've got Kat from IBM, who's going to talk to us about containers and orchestration on Z. We've got Richard from Microsoft, who's going to talk about mainframes in the cloud and whether they're mortal enemies or best friends. And then we've got Michael from Broadcom, who's going to talk to us about the Zowe CLI. And then we'll get all three of them together at the end for a Q&A session. So if you can hold all your questions until don't hold on to them, if you can put your questions in the chat or on Slack, and then we'll go through them all at the end and get a conversation going around each of those questions. And then we've also got Herb joining us for a few minutes at the end to talk to us about Advent code as well. So with that, I'll hand over to Kat.
Okay, thank you, Sophie. So I'm sharing my screen. All right, can everyone see that okay?
Yep.
Yep, okay, awesome. All right, so hi everyone. My name is Kathryn Briscoe and I'm a design principal at IBM, which means I design and lead the efforts around user experience on products on our mainframes. And my particular focus is working on containers and orchestration on Z, and in particular ZOS. So I thought I would just quickly go through containers. What are they? Kubernetes, what's that? And then a little bit about what we're planning to do on Z around containers and Kubernetes. So I apologize if you know what these things are, but I wasn't quite sure about whether people knew about it or not. So I'll just go through it fairly quickly. All right, so what is a container? So you might have heard this term used, bandied around quite a lot, and it kind of falls into two different things. So we've got something called a container image, and this is a unit or a package of application code and all of its dependencies, so its configuration, the runtime it requires, and anything else. And it's like packaged up into a binary object that you can then deploy into environment and run. And one of the real advantages of that is that because the image contains all of the dependencies that are needed, you can move that between different computing environments. So sometimes people talk about container images, sometimes they just talk about images. That's effectively what it is. It's like a package of the application and all of its dependencies. And then we have container instances. So this is basically you deploy a container, so you run it, or you can deploy an image, you run it, and that instantiates that thing. And then the application is running with this runtime inside it, and that is isolated from other things. So Linux has things in the operating system that will make sure that that particular instance is isolated from other things. And if you go and read up, you might read about namespaces and C groups and things like that, if you read up about container isolation. So containers are operating system specific, and they're also hardware specific as well. So today you can run containers on different flavors of Linux, and you can also run containers on Microsoft Windows as well. What you can't do is run Microsoft Windows on Linux and Linux containers on Microsoft, so that they are sort of different. And the really important thing is that containers are the currency for cloud. So applications, if you want to deploy those into the cloud, then you package them up as images and you deploy them and run them as containers. So Kubernetes, you might again have heard of this, but this is an open source collaboration around container orchestration. So as soon as you have more than one container, you need to think about the best way to manage that. How are you going to deploy it? How might you scale it? And then how do you know what's going on and what's running? And this is where Kubernetes comes in. And it started out as an open source project from Google, and it has grown in popularity to the point where it now forms the base for pretty much all of the major cloud platforms out there. So Red Hat OpenShift, Google, Microsoft Azure, all of those, IBM Cloud as well, all run on top of Kubernetes, and they build services and additional things, different additional features to make it really attractive to run your applications in those cloud platforms. So just briefly on the architecture, Kubernetes, it has a user interface, it's got a dashboard, you can look inside and see what's going on, but it also has a really powerful command line interface called kubectl. And what that does is, whether you're using the interface or command line, those things talk to a control plane. It used to be called a Kubernetes master, but they redid the terminology. So now you'll see references to a Kubernetes control plane. And that has a number of components that also run as containers, actually, and that controls what happens inside the cluster. And a cluster is basically a set of nodes, a compute resource where you actually want to run your containers. And because you might want to run a container or a set of containers together, then they have something called a pod, and that's the unit of deployment for your application. And you can have one container in there, that's pretty typical, but you can also have more than one as well. And what Kubernetes will do is it will figure out the best place to run your application based on the available compute resource. So it handles all of that for you, and it has lots of smarts in the box automatically to figure out where is the best place to run your application. Now you see Docker here. So Docker is a container engine that will run container images for you, but actually Kubernetes uses Cryo and runC now. So there are different container engines out there which will run your container images. Docker is probably the most popular one that you might know of, but there are other ones in the industry as well. So what do you actually do with images and containers? So because you can containerize most things, then what you'll see is that when we talk about cloud native deployment or cloud native development, what we're really talking about is bringing together containerized software and deploying that and allowing developers to quickly develop their applications and deploy them into an environment and into production. So an example might be you containerize your IDE, you containerize your compiler, you containerize your pipeline, and you containerize your runtime, and then you deploy all of those things as a stack, and then it gives the developer one thing that they have to deploy, and it does all of the work behind the scenes. So an example would be Red Hat Code Ready Workspaces, where you click on one thing and it gives you a stack of containerized technologies, and then what that means is you then log in to a cloud environment, and then you just do all of your development in there, and there's no need to install an IDE. You don't have to worry about that. You just go in there and you've got everything available to you. And then you can use your cloud platform to see all of your developer workspaces, your builds, your running applications, because they're all containerized and orchestrated, you can see them all together. So, that's one example. But another example might be if you're just developing locally, so you've got your IDE on your client, but you need a way to deploy some application that you're playing around with, then you can go to your cloud platform, you can look through the catalog, you can say, I'm developing this Node.js application, for example, and then you'll pick from the catalog the thing that you want to deploy, the runtime you need, hook it up to your GitHub repo, and then it will do the automatic deploying of that application as you're coding it and committing to your GitHub repo. So there's lots of nice features for developers to quickly get started and deploy their applications into a cloud platform. But it's not just about that, it's also about pipelines and orchestration. So what happens if you want to move beyond just developing an application, but you need to move it through different environments. And this is really where you can have DevOps workflows and Jenkins pipelines and Artifactory and Kubernetes, which will sort of take your application change, move it through a pipeline, save all the images in Artifactory so you've got them as a reference, and then deploy them automatically using Kubernetes. And you know, all of this flow allows you to not only develop quickly, but then get those changes from a development team through into production. And some people we speak to, they can develop and change their product and get it into production the same day. So, you know, you can be really, really quick depending on the application. And so really, you know, when we think about the benefits, certainly it's a way to package an application and all of its dependencies, so you can reliably and also repeatedly deploy that into different environments. That application's isolated in its container from other applications. So, you know, if something goes horribly wrong, it's not going to interfere with other things that are running in that same environment. And also another fact is that, you know, all of this technology is built on top of very vibrant and innovative ecosystems. So there are plenty of companies and people who are really passionate about these projects contributing on a daily basis. So lots and lots of innovation in this space, loads of really cool tools that are all aimed at trying to help develop, deploy and manage containerized applications. All right, so that's the general picture. Sorry, I whizzed through that really quickly. So if you've got any questions, then, you know, please do write them down in the chat. So containers and orchestration on ZOS. So last year, feels like a long time ago now, IBM made a statement of direction. So what we said was, you know, well, hybrid cloud and the IBM Z strategy is, you know, mainframes are critical to that. And what we want to do is to deliver a container runtime that can run on ZOS, and also to deliver Kubernetes orchestration to manage, you know, containers that run in that container runtime. So what we were saying here is that we want to provide the same capabilities that you get in your cloud platforms and provide those for ZOS applications. So this is, you know, applications that might run on Kix or IMS, maybe in Liberty, or even standalone batch applications like, say, Java, for example. But you would have the opportunity to package those up in an industry standard way, so build them, and then run them and orchestrate via Kubernetes. And this is effectively what I'm working on at the moment. So the idea is we want to provide some of these best practices, industry standard tooling, and bring that sort of experience to our ZOS developers and ZOS operations folks too. So I did put this slide in just to sort of show some of the benefits that we would like to bring. These are some of the things we've been talking about with clients to get validation. You know, looking at how do we make sure that we can build applications and deploy them into development, tests and production in a consistent and reliable way. You know, we often hear that test environments don't match production. So, you know, can we use containerized applications and building of those applications to make that better, providing industry standard orchestration. So if you've got front end and back end parts of your application, then you can use the same orchestration to deploy both and connect both together effectively. How am I doing time wise? Standardization. So, you know, we've talked about providing a standard way to package any application. So, you know, you could package a ZOS application in the same way that you could a cloud application. And it might also bring benefits in terms of if you've got an application that might run on Linux on Z or just on Linux today, having the opportunity to sort of use the same approach and techniques to then run that on ZOS so that it could be close to the data or perhaps reduce latency, those sorts of things. You know, that would then be another option for clients. They could choose where they want to deploy that application. So I'll probably stop there as I whiz through that really quickly, but hopefully that was a good little intro. If you've got any questions, you know, please put them in the chat, and then I'll hopefully be around at the end to answer them. Childcare emergencies withstanding that.
Great, thank you. That's really good. So yeah, please put your questions in the chat. And with that, over to Richard.
Brilliant. Thank you very much, Sophie. Let me start sharing my screen. Okay, hopefully hopefully you guys can see that. Yes, give me, there we go. Let me just switch the display around. Okay, so hi everybody. This is a group of people, many of whom I am familiar with. So it's really nice to be back and talk to you guys. I was trying to think of a fairly provocative title, and actually I realized I didn't put it on the slide, but this question about, you know, mainframe versus cloud, and you know, kind of best friends or mortal enemies was quite an interesting thing. So I thought that might be something that I would enjoy talking about and you guys would like hearing about. So let me start with a few assumptions before I talk a little bit about who I am and why I'm talking about this subject. So a few assumptions first of all. So let's assume for a minute that most people are enthusiasts of mainframe technology and that you guys understand what that is and how it works. But you know, cloud is something that you're relatively new to. So that's one assumption. You're curious about how the two fit together. And the last one, it's been a long day. Nobody wants to sit through hours of slides with lots of words. So I try to keep this very picture focused where possible. Okay. So my plan is to do this as a bit of a, you know, Cloud 101. So what is it when we're talking about it? You know, why are people wanting to use it? Who is using it? And then really have a look and see, well, you kind of the mainframe versus cloud discussion. How do I see that, and how is the world exploiting these technologies? My plan is to not talk about products. So full disclosure, I work for Microsoft. There are certain perspectives that I only have the data to access to talk about that are from a Microsoft perspective. So full disclosure there, but I won't be talking about products particularly. And this is a bit of fun, right? This is after hours, guys. So please bring comments, please share your ideas. I'd love to hear them. So I look forward to it. So the reason that Nick and the organizers have asked me to talk about this particular topic today is that until June of this year, my background has been in IBM. My background has been working with mainframe technology, which I've been doing for 15 odd years up until this year, in fact. So this is an area that I know very well. I understand ZOS. I understand a lot of the things that are being talked about and that many of the folks on this call are very enthusiastic about. And then since June of this year, I joined Microsoft to work in the Azure Cloud team. So I do a role across EMEA, which actually is not wildly different from what I've done before. I think there were many surprising things, many similarities and many differences in the work that I do and the experiences that I've had since joining Microsoft. I think some of the similarities, I speak to the world's largest companies. You know, they in the past they've said, look, you know, we need to deliver our services more efficiently, more quickly, at greater scale. You know, how do I do this with IBM mainframes? Well, now I talk to the world's largest companies about how they deliver their services quicker, faster, cheaper in this world of cloud and AI and mobile with Microsoft Azure. So there are some similarities and there are some surprising things, right? There are some surprising things that I've learned. And actually one of the surprising things was the number of people in Microsoft who are specialist engineers in ZOS, in mainframe technology. And not because they've joined from somewhere else, although some of them has, but the kind of their day job is to understand ZOS and how to work with it and how to build patterns that combine some of the components of Microsoft services with some of the components of mainframe services. But let's just hold that thought. We'll come back to it a little bit later. But it was something that I was quite surprised by. I think probably one of the biggest differences, and this was an earth-shattering difference to me, was the difference in stakeholders that now have interest in my job. Very specifically at this time of year, my children are very keen to understand, oh, so Microsoft makes Xboxes, and Minecraft, do they give them away at Christmas? Sadly, the answer is no, but it certainly has changed the way that my family speaks to me about the technologies that they use, and particularly the kids. But there we are. Right, so that's me. That's what I'm planning to talk about. Let's dive in. I've got the chat up next to me, so I'll try and keep an eye on that. So do please ask questions as we go through. So let's start with a little bit about what we mean by cloud. Now, I wasn't quite sure at what level to pitch this, so I kind of said, right, let's start at kind of level 0 and kind of build up from there. And hopefully I don't turn too many folks off who probably know this. So when we think about some of the elements of cloud, this is a very, very common diagram that is used to describe the different parts of what we're talking about. So on the left-hand side, we think about the very traditional way that we've always built IT infrastructure, components, applications, and it's from all of the physical compute capabilities, networking, storage, physical capacity, operating systems, virtualization, applications, all of that stuff that we would kind of build as a stack as ourselves. And what differs between the way that this is being delivered from the left-hand side to on the right is the fact that people are now consuming it in that service mindset, that service model. So I think many people are familiar with this concept of IaaS and PaaS and SaaS offerings, which is basically splitting out who is responsible for different parts of this stack. So from an IaaS service or an infrastructure as a service perspective, this is about saying, look, somebody is going to provide you a service for the physical infrastructure, and then you're responsible for delivering, the operating system, any virtualization, all the way up to the applications and data. So that's kind of what you see from an IaaS perspective. And then from a PaaS perspective, it's saying, look, we're going to give you all of the pieces all the way up to your containerization, but you guys provide your application code, you guys provide the data. All the way up to SaaS offerings, where you're actually just providing the function that you want to consume. So somebody else is rolling out application versioning, all of that kind of stuff. So that's kind of how we see it in terms of the physical infrastructure. In terms of where that sits in an organization, so you can have private cloud environments where you're building components for that cloud service and doing that inside the organization. And you can have public cloud components. So this is being hosted by somebody else providing these services. I think the interesting thing here is this as a service mindset. And what really differentiates the traditional ways of doing things with, actually, this is private cloud now, it is about this consumer mindset. So the ability to say, look, I've got a bank of compute capability out there. I want to as self-service, I want to be able to spin it up and tear it down. I want to be able to, pay per use on a per second basis or a per amount of time basis. And all of the automation that wraps around, actually, I'd like one of these for a period of time and then it's going to expire. And all of the patterns and building blocks, rather than having something that's bespoke and unique each time, it's I need X amount of compute and Y amount of storage and Z amount of networking. And actually the ability to have that building block and that rental mindset is really what sets apart what's happening over here on the right from what's happening on the left. It's not just the physical building blocks that differs between the two. You think about this in terms of what's happening in your own data centers versus what's happening in cloud hosted environments. Actually, what organizations are looking for is almost entirely a hybrid approach to this. So they're not looking for just one thing. They're actually looking to exploit different aspects of each. And really it's about saying, well, where is the application that I need to run? Where is it best suited to run? And how do I exploit it in the best way there? And I'll come back to the hybrid discussion a bit later, because I think it's quite key when we think about what Kat has just said about containers and mainframe and what we see in from a cloud perspective. And from my discussions, from a Microsoft perspective, this is something that's very interesting, because it's an area where we say, okay, well, how do we deliver this piece, which we understand very well? More and more, we're building Microsoft components, Azure components in the data center, but actually organizations want to be able to see this kind of common view of all of your capability wherever it is. And that's why some of this kind of mainframe and cloud stuff is so interesting to me, because there are potential ways that you can do that in a much more effective way. So this is the kind of what is cloud and a very simple cloud 101. let's have a think about why organizations are using cloud. So there are a few different reasons, right? So some organizations are just starting out, right? These are startup companies. These are organizations that, never mind a data center, they would, traditionally they would have, bought a few servers and shoved them under the desk to run their website and different ways of doing things. But this is a really nice way for an organization to just step in to start using the services that they need. They might not be IT folks. They might just want to consume those SaaS offerings or those PaaS capabilities and simply stitch services together to suit their needs. And if you think about people who are on that journey, they're kind of going from zero to hero, and kind of they're zero today, but they don't actually know where hero is. So it's a very useful way for them to get started in this space. The other group are those organizations that are growing really fast. And this is an interesting one because there are actually two dimensions to this. The first one is when the organization might have an IT facility, they might have a whole data center, but they have workloads that are very cyclical. So they run at capacity, but at the end of a quarterly cycle or an annual cycle, they have a massive ramp up that they need to accommodate. And so they have all of our functions are contained within our IT function today. That's very nice, but we need to be able to meet that massive spike for the 1, 2, 3 days, hours that they need it. And so that ability to kind of scale right out into cloud services is something that's very attractive for them. So that's the second one that we see. The third one are the organizations that want to try new stuff. They have no capacity or no skill set to be able to do that in their organizations today. And these are people who are trying things like, sometimes they're doing new kinds of data modeling. So they're trying to use some of the AI models that sit as PaaS services. Some organizations are wanting to do edge of network stuff. So if they're dabbling in the Internet of Things for the first time, actually they don't want to have all of the networking and security and governance and build capabilities that you would see around IoT devices. So that's the way that they're trying out these new things. And actually, if we look to the future and see the new, the really kind of bleeding edge stuff, you think about quantum computing, it's unlikely somebody's going to embed a quantum computer in their data center. So they're wanting to try those new things. Actually, what they might be trying to do is they might be trying to step into a new geography. So imagine they've got an IT function in Europe, for instance, and they want to stand something up in a new service in the US. Actually, there might be some requirements that the data has to stay in the US and not leave, or vice versa. And so what that means is they can take their functions as they exist and deliver them in a different country without establishing a new data center. So some folks are trying to do things in a new kind of way. Other people are looking to optimize their IT, right? So you remember the diagram that I showed a moment ago where you had your very traditional way of doing things, and the kind of consumer mindset, the as a service mindset that we see as a very traditional cloud pattern. One of the things that we see for optimizing IT is, well, how do we learn from that provisioning, deprovisioning, control, rental model in the cloud, and how do we apply that on-prem? So do we take those principles and apply them on-prem, or do we take some of that existing environment and deliver them cloud? And actually, organizations are doing a bit of both, right? They're moving some services into cloud and they're optimizing them that way. And in some cases, they're leaving the components in cloud, but they're just applying the same principles to say, look, let's stand up this environment, run it for a few days and tear it down again. And actually, this is a very nice way to optimize what organizations are starting to do. And then the last one is the group of organizations who are leaving completely exiting the data. So they don't want a physical footprint. They don't want the physical infrastructure anymore. And interestingly, this isn't a new pattern, right? So organizations in the past have outsourced their data centers and they've been run by other, third-party organizations. And that's been done and it continues to be done today. But one of the things I was quite surprised about is for the organizations who are not doing that, they're actually moving all of their services into cloud environments. And I was surprised by, not just that people are really doing that, but actually how far along the journey that they are. And some have, genuinely moved into that space. So these are kind of the 4 or 5 reasons that organizations are taking advantage of cloud. And really here, I'm talking about public cloud. I'm talking about public cloud, in some cases hybrid, but mostly, why are organizations using these cloud services? I will come back to mainframe, I promise. So who is using cloud, right? Who is using cloud? Now, if you Google who is using cloud, you can't, sorry, if you Bing who is using cloud, you can't find, the list of customers. So I borrowed this one as a Microsoft Azure chart. So here are just some of the organizations that are using cloud, and certainly using Microsoft Azure Cloud. I think there are a couple of things that I wanted to draw out here. This is across a whole load of different industries. So you've got automotive in here, you've got retail, you've got banking, you've got travel and transport, you've got manufacturing. A whole suite of people are using this in lots of different industries. I realize this is a very US centric chart, but it was a useful one for me to lay my hands on at the time. I think the really interesting thing for me is this number up here. So the vast majority of the world's largest companies are using Azure. They're using cloud, right? And when we think about, and I can't remember if we touched on this call, but we know it's true, right? Some of the world's largest companies are using mainframe technology. So clearly these aren't mutually exclusive technologies. There, you can see them and the overlap that's coming together here. And so we kind of get into the crux of the discussion today, which is, cloud versus mainframe. And we often think about this in combative terms, and actually it's one or the other. And actually one is going to signal the death knell of the other. And I think the reality is very different. So this is the perception, there's kind of this tussle for where workloads are. And yeah, okay, there are workloads shifting around, and that is what it is. But I think the reality is very different, actually, because if you look at what we see in organizations today, sure, we've got kind of cloud, we've got mainframe, but actually inside of the organization, you've not just got a mainframe. Okay, you have multiple mainframes, you have multiple high-end Unix systems, you have multiple Linux, Unix, Windows servers, and these are all being built very traditionally. You have more and more organizations are building out private cloud patterns, so you've got much more ordered and orchestrated components here. And the idea is to kind of try and bring some of these together. On the flip side, you've got outside of the organization, you've got cloud, and cloud is not a single entity with a single service. You'll have a cloud with dozens and hundreds and thousands of different services as well. And to add to that, you won't have one cloud, there are multi-cloud. So where I talked about hybrid cloud before being very common, actually the prevalent pattern is hybrid multi-cloud. So you're tapping into lots of different public cloud providers, as well as your components on-prem. And it doesn't stop there, right? So it doesn't stop there, because in addition to all of that, you've got all of your edge components. And this is interesting as well, because not just places that are in kind of very highly rigorized, structured and ordered environments, you've got a lot of this stuff that sits out in the wild. You've got all of these things. Everyone's wandering around with a smartphone and laptops and games devices and, satellite IoT devices and augmented reality services. And the reality, the real reality here is that for us as consumers and for companies who are providing these services, you've got loads of data flowing from these components across the whole lot. You've got mainframes that are providing core services and core data sets that need to feed the rest of the organization. You've got new kinds of services being stood up over here that allow connected cars and HoloLenses to talk to each other and communicate. And the real pain point for organizations is, how do we manage this complexity? How do we make sure that when we deliver a service, we deliver it in harmony with all of these different platforms? If you're delivering a new function in your mainframe application, unless you're surfacing it out here at kind of the experience end, it's useless. Similarly, you can't deliver new services out here unless you kind of daisy chain them all together to have that end-to-end piece. And this is very painful for organizations, as is the ability to manage these, right? One of the things that is talked about a lot is the security of the platform. But actually, if you've got something over here on the edge of network that is vulnerable to attack, then that can manifest its way all through the network. So the ability for an organization to apply a level of consistency about delivering applications. You think about what Kat was talking about a moment ago with the ability to have containerized services, so that you've got those much more manageable building blocks to deploy capability, to manage the health of those systems and to secure them as well. That's kind of the sweet spot of where we're trying to get to in this hybrid multi-cloud world. Now, if I come back to what I talked about right at the start, the surprise to learn that in Microsoft there are ZOS engineers and mainframe engineers. And the reason that there are is because when we're building our products that sit out in cloud or even on-prem, we need to be able to integrate with the platform. We need to be able to understand, well, what are the interfaces that are surfaced to be able to deliver applications, for instance. So if you've got an organization that sits out here and they're using Azure DevOps capability, well, you can deliver that service out here, but you can also deliver in the same step COBOL applications into Kix and have that pipeline and have that delivery vehicle that allows you to do that. When we think about containers on here, I think one of the things I'm really interested in is how, when you're managing services out here in actually whichever cloud you're managing and running with, how you manage and orchestrate that end-to-end service right into the mainframe as well, with containers on the mainframe, or containers on cloud, or containers on private cloud on-prem. I think that's very interesting. We have a session coming up in just a moment on Zowe. I've been in calls with our engineering team and the Zowe team, right, who are interested, well, what's Zowe providing? And we'll learn about that in a minute. And how does that dovetail with what you can do from a Microsoft perspective, from an Azure perspective? And so I think the reality is that you have this massively heterogeneous environment, and we need to start thinking about ways that we can help organizations deliver things with greater consistency and greater efficiency. Okay, I have no idea how long I've been talking for. Far too long, I can see. Okay, final thought, right? Final thought. I hope this has been interesting. I hope this has been useful. The stuff that I see is that enterprise services are everywhere. I mean, they are really everywhere. They're in data centers, they're in cloud, they're on smartphones. I even found out a couple of months ago that they're in space as well. It goes above and beyond cloud. It really does, pun intended. It's amazing. And this hybrid multi-cloud, idea is really powerful. It's really important, but it's tough for customers. It's tough for organizations to be able to embrace it and place trust in what they're providing wherever it is in the network. And I think the thing that I think is so important is that when cloud versus mainframe, this is kind of going beyond the platform discussion now. We're kind of getting beyond that. Yes, there are strengths of different aspects of different platform, but actually this is about being able to deliver a capability for an organization with consistency wherever they want to deploy it. And I think that's the kind of takeaway for this kind of cloud versus mainframe story. It's kind of actually, how do we bring this all together to make it simpler and more effective for organizations to take advantage of? Okay. So hopefully I've ticked a few boxes, talked a little bit about cloud, hopefully not talked too much about product, and just kind of painted a vision on how we see this kind of hybrid multi-cloud world.
Great, thank you, Richard. And there are some good questions coming in the chat, so we'll come back to them during the Q&A session at the end as well.
Great.
Thank you. So over to Michael.
All right, thank you. And thanks, Richard. I tried to touch on Zoe's viewpoint to solve problems related to multi-cloud hybrid environments and things like that, to provide a consistent approach across the enterprise to delivering software. So let me share my screen. Should be able to see my screen now. Can someone please confirm?
Yes, we can see it.
Okay, thank you. So as part of the cloud modernization and the mainframe session here today, I'd like to present an introduction to the Zowe CLI. So a brief disclaimer that this particular presentation is for just informational purposes only. And then a little bit about myself professionally. So I started here at CA Technologies a little more than 6 years ago, which has now been acquired by Broadcom. I'm experienced developing ZOS applications as well as modern interfaces for some of our mainframe tooling. A few years ago, actually about a little over 4 years ago now, I transitioned into a product owner role, product management role for what became the Zowe command line interface. I am now a technical steering committee member for both the Zowe and COBOL programming course projects underneath the Open Mainframe project, which is part of the Linux Foundation. And I'm the Zowe CLI squad lead. And then a little bit about me personally. So when I'm not at work trying to deliver software with greater speed, I'm typically at the racetrack trying to be faster there as well. So on the weekends, a hobby of mine is to race 410 sprint cars. A few facts about those are that our engines deliver over 900 horsepower. We only weigh about 1,400 pounds, and that giant wing on top provides downforce to try to get some of that power to the track. And then on the left, when I'm not at the racetrack, I enjoy hiking with my wife Shannon and my train walker coonhound Mira. So now let's jump into today's agenda. I'll talk about an introduction to Zowe as a whole, and then try to narrow in on the Zowe CLI specifically. Talk about integrating mainframe into enterprise CI/CD pipelines. Richard touched on trying to achieve consistency across organizations and how we deliver software. And I think the Zowe CLI provides a lot of benefits for doing that. I'll provide a brief demo at the end and talk about some additional use cases and resources you can tap into to learn more. Okay, so introduction to Zowe. So Zowe as a whole is a modern open source platform for the mainframe. It consists of a variety of components, including the command line interface, which I'll touch on more later in the presentation, as well as an API mediation layer, extensions for popular and industry standard tooling like Visual Studio Code. It also provides a web UI and software development kits, which I won't touch on much in today's presentation. Again, the goal, one significant goal of Zowe is to bridge the gap between mainframe and enterprise DevOps. So at a high level view, this is what the Zowe ecosystem looks like. And Zowe as a whole has been made possible by the emergence of REST APIs for various services that live on the mainframe. And as you have more and more services becoming available, you need a means to manage those services. And the Zowe API mediation layer provides that means. And then there are additional consumers of these APIs, including the Zowe SDKs, which are also used to build some applications in Zowe, such as the Visual Studio Code extensions. There are extensions coming out for other IDEs like IntelliJ, as well as the command line interface, which I'll be focusing on today. Before jumping into the CLI, though, I want to talk about the emerging suite of Zowe conformant APIs. All of these APIs integrate with the API mediation layer, and you can see multiple vendors becoming part of this community, including Phoenix Software International, Broadcom, IBM, and ASG. Now, I want to demonstrate in pictures the value of the Zowe API mediation layer. So here we see 3 different consumers of REST APIs. We have Ravi, Michelle, and Tyler interacting with mainframe services. And if they're all interacting directly, each one of these ports has to be opened on the network. They have to be able to access them, and they may be accessing them in different ways. Maybe some they would be accessing username and password, others requiring tokens, some requiring certificates. And it's difficult to, one, secure this environment, and 2, it's very administration heavy. You have to possibly open tickets to open up ports for different services and things like that. The solution to this problem is the Zowe API mediation layer. It provides a better user experience for consumers by providing a catalog where folks can view available services to interact with on the mainframe. It also secures the network by requiring everybody to access services over this single port. And it allows for additional benefits like redundant services. So if one service goes down, you may not even notice it as an end user if there's a redundant service in place. And then just briefly, a little bit more detail on how it secures the environment. API mediation layer also provides for single sign-on and standardization of how services are accessed. So all communications done over HTTPS, you log into this API mediation layer, receive back a token, and then you can access the underlying services. That's also recently been enhanced to accept X509 certificates as well, if that's required at your organization. Moving on to the growing ecosystem of CLI plugins. Here we see, again, we have vendors from multiple companies integrating into the space, including Phoenix Software International, Broadcom, Micro Focus, IBM, and many different extensions. So you can access a lot of different services today through Zowe CLI. And then on the other side, beyond what you can access on the mainframe, since you're accessing these services from a distributed environment now with the Zowe CLI, you can leverage all the familiar industry standard tooling that's likely used on the enterprise side of the house. These are IDEs like Visual Studio Code, scripting languages like Python or TypeScript, CI/CD orchestration tools like Jenkins or GitHub Actions, task runners like NPM scripts, code quality tools like SonarQube, and the list goes on. But there's basically all these tools that are now available for mainframe development that previously you couldn't really tap into that value as easily. And in addition, there are millions of packages on public registries that if you allow folks to leverage, folks can request that software at your site for development purposes and then be able to develop applications more rapidly. Let me jump into integrating mainframe into enterprise CI/CD. So there's a lot of tools that they may have a UI, but you also commonly see CLIs because they allow you to quickly explore services in real time, but then also quickly abstract these basic commands into more complex scripts to achieve various use cases. Because, for example, you can use cloud CLIs like the AWS CLIs to manage deployment of services. You can do that same thing with the Zowe CLI for mainframe applications. And one nice thing about the Zowe CLI is it allows you to modernize in place. So you don't have to shift anything. You're just orchestrating actions on ZOS from a remote environment. So with that, I'll stop talking a little bit and go into more of a demonstration. So let me pull up my machine. Okay, so this is sort of my developer cockpit here. This is sort of what I work in when I'm working with the mainframe. So it's Visual Studio Code, which is just a modern IDE. You could invoke the CLI from pretty much any IDE you would choose, as it has an integrated terminal. I tend to use Visual Studio Code because Zowe and really the industry at large also offers a number of plugins and extensions for Visual Studio Code that provide integrated experience when working with the mainframe. But I have the Zowe CLI installed. And if I want to view what's available in the tool, I can launch Zowe Help Web to show me what different commands are available. And again, there's many different plugins. I just have a few installed here. But for example, if I wanted to check out files, list, data sets, and then scroll to the bottom, they show me some examples. And if I want, more complex examples, like how to get attributes of these data sets and different things, I can read the doc or check out other examples. But just taking one of those and running with it, if I return to my IDE and I issue a Zowe files, list, data set, you can see this will list particular data sets on the mainframe. So not a huge deal. A lot of folks initially when they see this, they talk, well, you could create a GUI for that, and we have integration with VS Code. I could pull that up and show that as well. But the real power in this comes in automating these things, because not only is it a user interface, it's also a programmatic interface. So now if I go, for example, into my scripts and I add, let's say, zlist, and just put that in here. Now I can just run npm run zlist, which in itself is somewhat trivial, but then you can combine these basic building blocks into more customized use cases. And also, since this is modern technology, modern distributed tooling, a lot of times the CLIs have integration with the IDE. So in this example, I have this npm scripts over on the side, and I could also run the zlist from here as well. And it would run that command. But that's a fairly trivial example. A better example is this CI project that is actually used for building, deploying, and testing a COBOL CICS application that lives and runs on the mainframe. And that can be as simple now as npm run build, which if we look at the scripts, it then the build runs build COBOL, which is this script, and build LNK. And we can see that I have a list of scripts over here. And we can see that under the cover, each one of these scripts are powered by Zowe CLI commands. So it's compiling the COBOL element, it's building the LNK element. And then once this compilation completes, we could do an npm run deploy, which is going to do a little bit more than compilation. It's going to copy the appropriate libraries into the test environment. It's going to run a bind and grant job, ensure that completes with the right condition code on the mainframe. And then finally, it's going to issue a new copy in CICS to refresh the program. And then finally, we can do npm run test, and it's going to run a suite of automated tests that have been developed using the Zowe CLI to run different actions on ZOS. So in this case, it is it's going to fail because I need to make an update to the program. So I'm actually going to make an update to the program, and there's different, a lot of times on the mainframe, you'll have code stored in a mainframe specific SCM, such as Endeavor. There are other ones as well, and there's integrations with those. For example, Micro Focus also has a CLI plugin to integrate with their SCM on the mainframe. But in this case, I'm just going to pull something out of Endeavor. So I'm going to recall a command I had typed earlier to retrieve an element from a particular stage in that SCM. Basically, I'm just pulling an element out of source control, and then I could edit it here. I'm going to skip a little bit of this to save a little bit of time, but essentially, 242, here we go. We can make a change to our application, save it, and we will upload this back to source control. And again, there's greater integration than this with Git and Endeavor. I'm just showing this as a sample use of a CLI command to pull it easily. But in this case, now my code's been updated, and I could rerun that sort of what I'll call the personal DevOps loop as a developer, just making sure all those tests pass, and I would rerun the build, deploy to test environment and test of that application. But I could also have that just trigger a CI/CD pipeline, right? Because all of this is easily integrated into Jenkins, and I could just click off a build. Now here, oops, that's because I kicked off this pipeline. But this is going to run through some code scanning, build, deploy, and test. And if we look, for example, in deploy, you can see that essentially it's just making use of the same personal automation I developed on my workstation, but doing it as part of a standardized process. So that ensures that all code before it's moved to the next stage in the development lifecycle has gone through a standardized process. And that's all defined in this Jenkins file. And a lot of times, like CI tools, they allow you to pass in certain variables or do things where they manage the secrets. So in this case, I'm having Jenkins manage secrets such as the host name of this system and also the username and password. But essentially, it's just running npm run build, deploy, and test, and then it's archiving these test reports. Let me just pull that open really quick. Okay, and we can see that just because I ran the most recent one, it had failed, and it gives me a document of that. Also, all of these commands that were run, they're all archived as well. So you can have like in context view of everything that the pipeline did and everything that the process did. So with that, let me just quickly return to the presentation. In addition to integrating mainframe into enterprise CI/CD pipelines, there are additional use cases, and I would encourage everyone to take a look at those on our blog site. So that those are medium.com/Zowe and medium.com/modern-mainframe. There are examples of combining Zowe with Ansible, using a CA JCL check plugin to verify JCL before you run it, and also automating Endeavor package shipments using CLI. And if you're interested in building a plugin of your own, there's also information on how to do that as well. I think that'll conclude my session, but if anyone has any questions, definitely feel encouraged to reach out to me at michael.bauer2@broadcom.com. Thank you.
Great, thank you. That's really good. It's always nice to see a demo. Okay, so I think we've got a few questions. So please, everyone, keep asking questions because we've only got a few so far. It's quite hard to find them through the chat. There's been a lot of chat about what defines the word legacy. So that's quite interesting. Matt suggested that we have an open mic topic on that in future, so that could be a good plan. Okay, so questions. The first one is for Richard. Wondering if you've heard of the recent announcement for the AWS mainframe modernization migration platform and whether you have any thoughts on it.
Don't worry, I am here. I'm just trying to push all the right buttons to come off mute and come onto screen. Yeah, I have had a look at it. I think I definitely think that AWS is very interested in the mainframe market, and I'm curious to see how how the approach goes. I don't know what's under the covers. I think a lot of it was announcement. I didn't attend the conference, but it's definitely you can see there's real interest in AWS and mainframe.
And then similarly, how do you think the mainframe modernization for COBOL to Java will shape up in the coming times?
Yeah, it's a good question. I think there's been a lot of and this has been linked to COVID stuff as well, and it's in some of the chat about legacy and old and where the skills are. And I think the real pain point here is when we think about old and people think about mainframe, often the physical infrastructure isn't that old, it's just a few years old. I think where people really struggle is actually is in the processes, and the applications are probably several years old, maybe decades old. The processes that sit alongside them are similarly aged. And it's about saying, well, actually, is there a better way that these applications can be delivered? Is there a better way to exploit the technology? In some cases, people are struggling with COBOL development. Okay, so can you bring Java into that story? Can you bring other languages into that story? How do you do that? And so And I think that's the reality. I think some people are looking to see, well, how could we do this with different languages? That can help. But I think if you took a COBOL application and simply were able to deliver that as a Java application, that wouldn't help. You need to modernize the processes that sit alongside it as well.
Cool, thank you.
Could I jump in on that one just a little
Yeah.
bit? So
please do.
also a little bit outside of Zowe, but still related. I'm a technical steering committee on the COBOL programming course, which really went viral early last year during the pandemic due to certain statements in the media around mainframe and the need for unemployment checks to get out. So there were a significant volume of folks coming over and trying to learn COBOL. And I think the fact that we were able to have those folks learn COBOL using tools that they were familiar with, because a lot of these folks were just younger university students and things. They were already familiar, they already used Visual Studio Code. They weren't familiar with COBOL, but the fact that they were able to use tooling in an environment that they were familiar with, I think helped them learn the language. So sometimes I don't think it's so much the language that is a hurdle, but also the tooling. If you have to learn new proprietary tooling to get on board, that becomes somewhat challenging as well.
Sophie,
Yeah.
can I say something here as well? So, I'm Matt Comer. I work with Kat, who shared on the first talk, and I'm thinking back to one of the very early MainframerZ events when we were in person at Lloyd's, and we had a great talk from a couple of new joinees to the company that was being shared, and they didn't realize, but they were joining a mainframe part of the organization. And for them, I think it was this scared, they were kind of like these rabbits in front of the lights of this dark world of this mainframe department that was separate from the rest of the organization. And they were kind of inducted to all this new terminology, green screens, and it was very scary. And I think there is this kind of concern of a skills gap of, as a lot of people that worked on the mainframe for years are in that place of retiring, moving on. And I think what Michael shared with Zowe and lots of other tools there, this move to open source tooling that is kind of common and familiar across the industry is appealing to the new people coming in. And I believe is really important to the survival of the mainframe going forwards is that people coming out of university, the new grads, the new people will be already familiar with the open source tooling. If the mainframe can incorporate that, and if the UIs and the experiences are similar, it's going to be much easier for people to onboard. And I'm waffling. A couple of examples that in our team, we've had new grads that are just really comfortable with containers, with Docker, with Kubernetes, with GitHub, with Jenkins, with lots of the tooling that you see in cloud. And so they've been really able to get going a lot quicker than the people in our team that have 20, 30 years experience in Z. And so it's been a really good bridge of the new grads helping the oldies getting familiar with the new technology, and vice versa. The people that have been around a long while are helping bring the newbies up in terms of some of the core stuff in ZOS that we don't want to lose.
Thank you. Yeah, I think definitely that's right. And I'm not seeing any new questions coming in, and I think that's actually a perfect time to introduce Herb, who's going to talk to us about the call for code, because that follows on quite nicely from that. So Herb, are you able to unmute?
Hello. Can
Hello.
you hear me?
Yep.
You see, it's almost like I planned this, these last two conversations that we had. Hello, everybody. Some of you mainframers for a while may have met me before. I am an academic at the University of Wolverhampton, and I have a long-term relationship with the UK mainframe community. So among other things, I'm an IBM champion for System Z. I look after a mainframe student society and have kind of been involved with the skills and learning stream at GSE for quite a while now. So one of the things, and there's some wonderful themes coming out of our conversations this evening, and it always reminds me that often we have similar conversations, and partly because we have different people every time, and that just reminds me actually maybe it's time to bring some of our previous kind of conversations back. Mainframes are often seen as quite a serious thing. Kind of big and expensive, and you have to do very kind of serious work with them. And one of the things that I've kind of taken an interest in, and this is often in partnership with Henry Cooper, a fellow champion who's based in the Netherlands, is actually mainframing for fun, mainframing for ribaldry and irrelevance and irreverence. What do I mean by that? Well, if you think about kind of skateboarders, right? How do they learn to skateboard? Well, they hang out with some people that like skateboarding, and they do tricks, and they watch their friends do tricks. And before you know it, they're really, really good at these things because they just enjoy getting involved and mucking around. And traditionally, because Mainframe was a little bit of a walled garden, that's something that we didn't get enough people involved in, mucking around and having a go on the platform. Now, the truth is, and I know this because I've been hanging around with mainframers for years, there are some crazy, mad, talented people on this platform who could do all kinds of things that you would never imagined was possible. And one of the things it's nice to do is every now and again bring them out of their shell and kind of give them a chance to show off those skills. So there is a global competition, and I'm gonna just in case Sophie decides to nip me off in a second, I'm gonna post some links in the chat here, and then I'm going to explain what they are bit by bit. So there is an annual competition. It's been running about 5-6 years now, and it is popular in the programming community, and it's called Advent of Code. And basically, it is 25 little challenges for a programmer could do, all themed around Christmas. So every day in the run up to Christmas, there's like a description of a little challenge, and I'll show you quite how silly they are in a minute. And the solution to it involves writing a program. So let me just share a screen here. Ooh, 1 second. It's one of those ones where you go, am I doing this right?
Marcus, you might need to make him a co-host.
Yeah, oh, he might have already. Ah, here we go, here we go. I'm going to share screen, but you don't need my... is that on there? Right, hang on. So that is, let me just take that back for you. So this is Advent of Code, right? And so every day you have these challenges, and it's 10 hours until the third challenge is released. And basically you sign up to do this. Now, to encourage fellow mainframers to get stuck in and have a go and solve these puzzles in mainframe languages, Henry and I have created a special leaderboard for people who are coding it in mainframe languages as opposed to any other languages. So the long kind of gobbledygook number that I posted is the code that you use to join this leaderboard. And basically everyone who's having a go in mainframe languages can join in there, have a go, win the stars, and you win a star when you kind of complete a challenge. And we're also posting our code as well, so people can kind of see the cunning ways that you were able to use your mainframe skills to solve that problem. So what is a mainframe language? Well, pretty much any language that runs on a mainframe. If you are doing it in Rex, that's cool. If you are doing it in COBOL, that's also cool, and there's a reason why I mentioned that. You could be doing it in mainframe Java. It doesn't matter. We're just keen to get mainframers out there and showing off their skateboarding skills in terms of the code. So let me give you an example of the type of things that they do. So you see now, I've won a couple of stars. I've got to be honest. I did it in one of the one of those fringe mainframe languages, because I'm at home at the moment. I had to do it in a fringe mainframe language, namely Python. But as soon as I'm back with proper access to a machine, I shall be converting them all over to something a bit cooler. So all of these tales start with a story about how Santa needs to find his sleigh or needs to find his presents, and he has to solve a problem in order to make them happen. And so there's a long kind of a description about, you know, oh yeah, the elves, that's what they need. Oh right. So now Santa is moving by submarine, and basically he has to use numbers from a file to generate another number to help him pass on to the next phase. So in this case, for the first one, he has to count how many times the numbers in a sequence either increase or decrease, and then to get the correct answer, to get him to the next puzzle. Oh, okay. And you can actually see the answer there, but forget that you saw that. You make the measurements from a file that they give you, and then you give it the correct answer, and you win a star. This year, because this is the first time we've kind of put it out there, because, you know, beforehand it was just a couple of us doing it, but this year we'd really like to see a few people getting stuck in and having a go. Our friends at Micro Focus have promised a tokenary prize for everyone who has a go in COBOL. So as a way to encourage you COBOL people to get the skills out, there's a little encouragement there. There is also a Reddit page where we're discussing it, and people are posting their examples. You can put your example code anywhere you like, in Pastebin, on GitHub. We don't mind, but it's really about getting mainframe people to have a bit of a go and show off those skills and share some of that knowledge and expertise. Dougie Lawson and Henry did a really good talk about it in GSE a couple of months ago, and I think that will be available soon. But really, that's all I wanted to say. Please come down, have a go, show us those skills, particularly COBOLers, because there are prizes. I thank you.
Thank you, that sounds good. I've only ever done the advent of code in Java, so I might take on the challenge and try and COBOL.
Yeah, do it.
Let you know. But yeah, looking forward to seeing how many people do get involved and do it. And I never make it through very many days before I get too busy. But
well, so this is the thing. I say a target for this year is just more days than you did last year. Right? So if that's just one, if that's just two, that's okay. That's good. That's more than before. I just think everyone should have a quick go.
Good point. Cool. Thank you very much. Okay, I'm just going to take the screen sharing back again. And we're very nearly finished. Okay.
So I saw in the comments, yes, assembler, would love to see some mainframe assembler on this too. Go for it, get stuck in.
Right, okay, cool. So thank you everybody for joining today. We really do want you to give feedback. Beth, can you post the link in the chat so people have it that can click on it? Yes, we really do want to get your feedback, because obviously we organise this in our own time, so we want it to be worthwhile. So these are just some of the comments that we got from the last event. So someone specifically asked for a modernization of the mainframe and cloud migration. So that's why we put together this event. So if anyone's got more ideas for themes, we'd love to hear them. If anyone's got ideas for talks, we'd like to hear them. If anyone wants to get involved in joining our committee, you can put your name down and stuff in the survey for us to get hold of you. So please do come and give us feedback.
And let us know what we're doing right, because if you don't tell us, we might stop doing it, and that's not a good thing.
Yeah. And please do keep in touch via all our different channels as well, so that we can carry conversations on and things between meetings rather than just at the meetings themselves. And with that, just thank you very much, all of you, for joining, and hopefully we'll see you again soon.
Thanks, Sophie. Thanks, Sophie. Appreciate it.
Thanks.
And Richard, just tell your kids Christmas is coming soon. But emphasize the first letter of each of those words to them, and I'm sure they'll be very happy with their Xbox.
That's sad.
Very good, Nick. Very good.